subdirectory. So let's just go ahead and try it again. And that should be in place. It has an extra key in it, which we can remove rather quickly. Let's just clean that up. Removing this extra key, and then re-key editing the file to bring us back to it. So this is now in place. So next, we will download and install PostgreSQL. So let's explore installation of PostgreSQL. So downloading the image, which allows us to install via the GUI and optionally via the shell from Enterprise DB. So download bin file from Enterprise DB. Now we've already downloaded it, but let's just show you how you would access it from the PostgreSQL website. So just navigating over to PostgreSQL.org. This will provide the links necessary to download. Navigate the downloads, and it's available for multiple platforms. Select the current platform links, and there are a number of installers for various flavors of Linux, including RPMs, Debian packages for Ubuntu and Debian, as well as Gentoo and CentOS RPMs. But the graphical installer is the desired method because it walks us through step by step. It's very clean, it's very easy to follow. These packages are maintained by Enterprise DB. This is a commercial support offering of PostgreSQL services. There are binary graphical installers available for a number of platforms that PostgreSQL supports, including Linux and Mac OS X. So clicking on the Linux package allows you to get that particular file. And select the HTTP website you sign up for, so we've already done that CCP files. Let's just reference it. So download from the last registered. And our task is, of course, to install. Now, the file is located currently in our Linux CBT directory, so we'll get it from there. Click over /Linux CBT, PostgreSQL. The next directory should reveal the PostgreSQL bin file, this is the file. So the SQL is root because we want to be able to have all of the items automatically created for us, including the Postgres user. And also we should run xhost to allow the root user to be able to write the graphical application to our local X server. Otherwise, the graphical installer will fail to bring up a GUI and resort to the shell-based installation. Let's just submit and execute that flow path. This will bring up the GUI momentarily. And let's check the permissions on it. And indeed, it's not executable, so let's change /X, and then we run. Normally you download files like bin files, they're not default set to execute. So here's the GUI installer. So it'll come up as self-explanatory. The default control installing PostgreSQL in /opt. And of course it's packaged by the commercial support providing entity, Enterprise DB. This is where it'll set up shop, /opt, PostgreSQL 9.0. Now, if you intend to mix, which is the default, by the way, your database files with the install tree, you need opt. And for performance reasons, you may want to provision opt on a distinct hard drive or distinct disk, or separate your data tree from the PostgreSQL installation files by manipulating config files after installation. So this is the default tree, opt PostgreSQL version, and any version will find all the files that pertain to the installation, including the binary files, default databases, etc. So click on next to data directory. This will be beneath the tree, but this is an opportunity to place your data elsewhere. So just note, you may optionally, as you can with any DBMS, indicate that data files be stored independently of the source tree, and this is of course for performance reasons. So for production startups, certainly consider separating the data files from the source installation tree of the application. But for our classic environment, we'll default to the default tree, which is the data directory beneath the version directory of 9.0. Here, prompted with indicating the password of the user account that will provide us with super user access or DBA privileges to the DBMS. The default account that we created is Postgres, and that is the account that will have full super user rights or DBA access, or SA access, for those of you familiar with Microsoft SQL, to the Postgres instance. So let's go ahead and specify the password for the Postgres user. This will ensure that you're required to present the password upon connection to the DBMS instance. As we mentioned in the previous section, the default port is 5432 on TCP, so this is a port that PostgreSQL clients like PSQL will default to, but it doesn't preclude you from specifying a different port. If you'd like to list on a different port, by all means indicate it here, and be sure to reference that different port when using your client utilities. Here we get to specify locale options, view the default locales that are available, or locales that are available, and the default locale will be UTF-8, but there's always support provided with these programs as well as UTF-8, C as well as POSIX. Now, notice the term database cluster. This does not mean that we're setting up PostgreSQL across multiple nodes in a clustered fashion of physical systems. This simply means that PostgreSQL will be managing or responsible for multiple databases by default when it's set up. It provisions 3 databases, which we'll see momentarily. So database cluster in PostgreSQL term simply means the management of more than one database, which defaults to 3. Let's click on next. It's now ready for installation. We'll just note that in the background. So files will be unpacked. And all unpacked, let's just note that a database cluster in PostgreSQL terms is simply the management of more than one DB, as opposed to multiple systems being clustered via the operating system in the event of some sort of fail scenario or failover. So at this stage, we have the option to launch the stack loader, which is an additional package which allows us to further customize PostgreSQL. We'll skip the stack loader for now. This is something we can revisit at another point that allows us to incorporate into the PostgreSQL build additional programs, drivers, and so on. Let's go down, finish, and explore the tree that's set up. So second half is to explore the footprint. Now, these applications, it's very good to know exactly what's in place where. Now, we know that the tree has been set up to be opt, so if I need to opt, and tab confirmation will take us to the version directory. So this is the top level directory, PostgreSQL 9.0. This is the tree that's available, and we'll start by taking a look at the bin tree. The bin tree is a binary tree. It contains programs that run the server and clients, and the various processes that make up the server. So taking a look at this directory, you see a number of utilities. Of them, some of the important ones include, as we mentioned, Postmaster, which is a master process which runs as an instance called Postgres, which then runs other processes such as the auto vacuum utility, which cleans up and reclaims space for us, as well as other processes, such as the write-ahead log, for example. Some user-space utilities that are of interest include CreateDB, which is a SQL wrapper for creating databases from the command line. It executes the SQL command create database. There's also CreateUser, which allows us to set up users that are defined in the central user accounts database and may be used to connect to the PostgreSQL instance. DropDB is the converse of CreateDB. It drops the databases. DropUser is the converse, and CreateLine and DropLine are converses which allow us to specify various language settings. InnoDB is used during installation, and there are a number of other utilities in the directory. Of them, perhaps the most important client utility is PSQL. This is the terminal monitor. So let's just know PSQL is a terminal monitor. This is akin to MySQL. MySQL. It allows you from the shell to connect to and use the database engine, as well as to execute scripts, and to interact with the DBMS. So there are also ancillary utilities such as CreateDB, DropDB, which is the converse, so let's just note it here, create, DropDB, create, as well as DropDB, as well as create, as well as DropUser, which creates, drops, users. These are some common client utilities that are of interest. Switch server binary is Postgres, which is linked to the name Postmaster, so it appears when it's running as Postmaster, which is really just a special indication of Postgres. Postgres is a server daemon, so server daemon or server process. Now let's take a look at some of the other directories. So as we said, there's the index, DB, but that's not important at this particular point. We need to find documentation, and in fact we will symlink the documentation from the HTML directory beneath PostgreSQL into our web root so that we can access it. This documentation includes how to use the service, and can be linked. In fact, we'll include that as an intro task. So 3, provide access to docs via Apache. So the symlink, we have Apache, is set up and in a separate window, let's SUN, and navigate to that root, and select serve content from this directory. This is one of our build boxes. So the symlink in this directory, from the HTML subdirectory, PostgreSQL, calling it PostgreSQL, then we can access it from the browser. So soft link, and it's going to be opt PostgreSQL 9.0 doc PostgreSQL. We can sync it to have access to the HTML content. We can link it here as PostgreSQL docs. And then that'll become available from the browser for access. Let's just try, and that'll be via the IP address of the server or its name. And because since the path is browsable, we can just simulate it, small index array, and then PostgreSQL splices us into, that is the PostgreSQL docs, that is. And that places us right into the documentation, so we can reference any of the important items such as add a bookmark, and we'll have this as a subsequent reference. That's out of the way. So documentation's there. So the footprint, we've got two binaries, we've already symlinked, and let's just know what we've done. We've ln, symlink, opt, PostgreSQL, 9.0 doc, so let's get a full path, and that's PostgreSQL HTML into a web accessible location. So it's full front end for everybody helps. And that was linked into the following directory as PostgreSQL docs. So that's now made available for our reference. So the docs directory contains the official documentation plus contributed documentation. In addition, we've got a data subdirectory, and it contains the databases, the defaults, as well as the newly created databases as we move forward, navigating the data, as well as the config clouds. So this is the data tree where you'll find the databases, and again, this was the default option during installation that we elected to go with. We can split the data out to some other mount label we elected to place the data here. In this directory, we see the config files that we listed earlier. The main config file, PostgreSQL.com, notice its size about 18K, as well as the other config files, one for IDEN, which is small, and PG_HB for space access. So these are the two config files that are included with the main config files. In addition, in this data directory, we've got PG_log. Log files are stored in PG_log. So the default logging environment, which handles standard error, which means any errors that are generated during startup, during execution of queries, will be stored in PG_log. The write-ahead log, which ensures that transactions are preserved in the event of failure, is stored in PG_xlog. Let's just know that. So top level data config file, log files. And there's also PG_log. And this directory stores the log files, and the default is to record standard error, or STD-ERR, but that can be tweaked to include more information. In addition to PG_log, we've got PG_xlog, and this is the location of the write-ahead log. And the write-ahead log, as we mentioned, is to ensure that in the event of an abrupt or catastrophic failure that the data are preserved. It maintains changes to DB files at all times, so it keeps track of all changes at all times to ensure against failure. So those are two key directories beneath the data directory, which are exclusive of the data files used to support the default database and subsequently created databases. In addition, you've got startup options and data in a file name postmaster.ops or ops. And this contains the startup options. Let's just take a brief look at it. It influences the way the daemon starts. It's cat postmaster.ops. And this is the start screen that defines the way our PostgreSQL instance starts. Starts with a daemon and its data directory is the following. So data files are served from here. So if we PSF grep Postmaster to see if it's running within the process listing, currently isn't. And it needs to be started. In fact, it is running as Postgres. We see the startup options. So it was very set up. We started with the enterprise AD package. We see the startup options. Select the Postmaster.ops in the process table. Dash D, data directory, and so on. We also see those helper processes that we mentioned that appear to be as Postgres with some additional details such as the following logger, right-hand log, auto vacuum, stats, writer, etc. So these are the processes that make up PostgreSQL. The main process is the one above, which runs with the startup options defined in Postmaster.opts or ops. So now there's your information. Let's just note. The start is the start. The RDBMS post installation, which is obviously running when it started. And also that means there was a startup script in etc init.d, so let's just note that as well. etc init.d, and we'll get the exact name and paste it in, but as a consequence of installation, there's a startup script to save us any hassle, and its name is PostgreSQL-version, so presumably for subsequent releases, such as 9.1 and so on, they should appear accordingly. Let's paste this in, so this is the init.d manager, which allows you to start, stop, check the status, which we can run, by the way. This is real simple, so running it with status, for example. Tells us that the server is running with its PID, which we can confirm by perusing the process window previously run. Here we see that PID, which has been invoked by init.d, which is the first process ID, and then the subsequent helper processes all reference the master process. This is how you know the hierarchical chain that we mentioned is true, that the helper processes rely upon the master process to invoke those programs. So the init.d entry is set up, and otherwise PostgreSQL is contained beneath opt PostgreSQL version, so we need to look elsewhere for files such as note files except init.d file for the run script that is are contained within opt PostgreSQL version hierarchy. So that means that we'll find everything in that particular tree. Unlike if you use package, for example, for this system, the Debian package or an RPM package for a different distribution. So that's in place. Now, in order to access PostgreSQL binaries, we need to have the bin directory in our path. That's important because otherwise, if you try to access, let's say, PSQL, for example, let's look in your path. It won't be accessible. Now let's echo our path. You'll see that the directory is in root's path. And that is why PSQL and other utilities respond accordingly, because it's there. If we navigate one level back to bin, any of these programs may be run by the appropriate user if it's in the path. Now, we operate primarily as user on XCPT, which is an our-privileged user, so the key is to ensure that it's in the user's path, not XCPT's path. So Control-Shift-T, and we'll do a which PSQL to tell us if it's in the path, and it doesn't work, so it's not in the path. So to modify the user's path, we'll modify in our home directory the bash, either bash RC or bash profile file, either one will do, and we'll include a statement, usually it's bash profile, but it will work here as well, that this is for PostgreSQL, and that we will export the path setting it equal to whatever it currently is, as well as the following. So this will tag on that directory and include it in user XCPT's path. And if this is to apply to all users, then the exposure needs to scale or script copy to each user's using tag with a pending direction to each user's bash profile or bash RC file. So this will be applied to the user's startup environment. Now there's another variable that's of interest besides path, and that's each user. The default user with whom we connect to the PostgreSQL instance as the user with whom we're currently logged in as. If that user doesn't exist, then there will be an error with the client utility. Let's just note that we created that additional task. Update XCPT bash RC or bash underscore profile, wherever your settings are referenced, to reflect the following directory to access binaries. We're using the client binaries, of course. Now we should just note that PostgreSQL clients, just like MySQL, subscribe to submitting the currently logged in user's name as the DB username. This means if you're logging in as a user on XCPT, then the client will attempt to connect to the DBMS as the username on XCPT, which doesn't exist. So a workaround for this is to export the PG user variable, setting it to an existing DB user, such as Postgres. So we could, for example, add an export of PG user, setting it equal to Postgres in the user's bash RC file, which we'll do, but we'll show you that it fails when we explore in the subsequent section of the SQL terminal monitor utility, and then we'll update the user's file. Now, back to the shell for a moment. Just because we've updated bash RC does not mean we can simply run the utilities from bin. Notice, as a type PSQL, it fails because the path is not automatically updated. And if we were to close this window, for example, using Control-Shift-W, and open a new window, Control-Shift-T, and do a which PSQL, now we see that the file has been reread. So when we plug in, the new shell rereads the bash RC file, and now it's not passing. You have to open a new shell or source the file using dot followed by the file name for an existing shell in order to update your path on the fly. So for example, in this shell, which PSQL doesn't find it, but if we source our home directory bash RC, so we'll rerun the contents of bash RC, dynamically updating our path so that we can now find within the shell. Even if we're not able to close the shell. So now it's in our path. So any utilities that are there, such as create DB, create user, etc., will now respond because our path has been updated. That does not change, as we mentioned, the default user with whom we will attempt to connect to the DBS. That is always defined by the currently used accounts for the currently logged in account for a particular shell, which in this case is the user XCPT, which we'll rectify. So quickly, just to recap this directory hierarchy, let's just navigate back into the structure. Everything's rooted in the version directory beneath PostgreSQL, whether it's 90, 91, 84, etc. Then contains client as well as server binaries, which includes the various utilities that allow you to manage the environment. So some skip included, they'll go backup. We'll look at those definitely later. The data hierarchy contains the default databases and subsequently created databases must not have privileges to read the structure, which means we cannot interact with as a non-privileged user in files in these data. But as Postgres we can. There's documentation and items that pertain to PostgreSQL, like include files, the installer, lib. There's also embedded needed the uninstall script in this directory. And there's also Stack Builder, which allows us to add additional modules to the point. There's the PG environment shell script, which we didn't look at. This particular file contains variables that may be useful for any user running PostgreSQL clients, such as including the bin directory in the path. This prevents bin directories to your existing path as evidenced by the line. Setting the PG data variable. This is something that a server process would be concerned with. Default database, Postgres, which is one of the 3 databases created. Default user, PG user, or 5422 in the event that it's a different port, you can specify a shell variable, and some other items. So those are variables that are useful in the event that you have to customize your shell to access PostgreSQL instance in a specific way. So that's the tree. Those are the key items. There are other items, of course, those are the key items in this top-level tree. Next, what we'll do is use PSQL to access the DBMS to further explore the environment and continue our studies of PostgreSQL and SQL in general. Similar function to the PSQL non-interactive interactive command. This only allows us to communicate with Postgres in the back end from the front end. So in this PSQL, it's analogous to MySQL. And it features non as well as interactive usage, so it's non and interactive, which means you can execute SQL commands non-interactively or interact with the DBMS on the back end and issue commands one at a time and go back and forth. So it's analogous to MySQL. For those of you familiar with MySQL Terminal Monitor, it supports a number of features, including command history, which means you can reference your commands using up arrow, down arrow, which is that, up, down arrow. And it also supports tab completion. So for uniquely specified characters for a given command or identifiers such as a new object like a table, simply indicate those unique characters followed by tab will complete the name, just like we did in the bash shell. Commands terminate with semicolon and may wrap lines and have like space separators, which means you don't need to worry about your commands running over the existing line. So long as the identifiers and commands are separated with spaces, you are able to execute commands that stand on line. For example, I don't usually by system reasons, but so many characters that will fit within a given line. You should also note that, as we mentioned, it defaults PSQL to supplying the currently logged in user, which means you'll need to set a variable PG user in the event that you'd like to omit specifying the username on the command line. It's certainly optional. So our tasks that we'll be exploring here is usage related, of course. So let's go about first one, explore PSQL. Now, non-interactively, if you'd like to ascertain the version of the client utility, let's just go with PSQL. So our path to PSQL with the version option will return that information for you. Now, this tells you that the client version is 9.0, not necessarily the server version, but the client version. Now, providing you come back to only one PSQL binary in your path, then it should also coincide with the server version. But you can use various versions of PSQL to talk to the backend server, so that is something to keep in mind. You could use 9 to talk to 8, 8 to talk to 9. Also note that it contains support for command line entity, which is provided by the bash shell, and functions like the bash shell, so tab completion, for example, as we just mentioned, as well as command history. So one indication is to explore the version using the version option. How about connecting to the database and listing the available databases? With the get option, and of course, we indicate the view option that we connect to Postgres. This will do just that. This lists DBs and exits. Now, the first specify the option, let's just try to connect with the default users approvably. Now, PSQL is the help option returns the various options, which includes among them the help option, which lists the databases that are available to the query here. And the E option, uppercase, which is towards the bottom of this dump, indicates the ability to specify username. Each option has a long option as well, so you can specify either or. So PSQL lists all databases with default, try to connect to the local host and list all databases. Now we're trying to specify the password and indicate here instead of see if it allows us to connect. And notice it allows us to connect. Now why does it allow us to connect? Let's set grab PG. Let's see what comes up. We've already set PG user equals Postgres to this time. But if we were to unset PG user, for example, and then set grab to see if it's no longer there, so now when we connect, we'll try to connect this as a user with CDT, and notice it's failed. So the variable set to an appropriate user isn't successful, then you shouldn't have a problem connecting to the database. Now here are the 3 databases that are defined with the default build. Notice including all UTF-8, that is no surprise. Notice that all databases are owned by the user Postgres. Which you note, so let's just go through them. So note, Postgres, SQL, of course, installs the 3 default DBs. And they are, and down here, Postgres, template 0, template 1. Postgres contains user accounts, DB, among other things, such as statistics and information about the databases that are managed within the cluster. So it's a management database. Template 0 and template 1. Now, template 0 is a vanilla database that can be used to reconstruct template 1 and databases that have been derived from template 1. So vanilla, original, DB. Template 1 is a copy, so a copy of template 0, and it may be extended and is used to generate new DBs. So by issuing create DB from the command line or execute create database and database name from within the terminal monitor of PSQL, you effectively copy template 1. So template 1 is a template, and it is identical initially to template 0. The template 1 is the DB that you want to change or to interact with. And if you'd like those changes to be cascaded or propagated to newly created databases, so this is the template database to manipulate. The code again initially identical. Template 0 is the vanilla version DB that should not be touched. You can only use to eventually recreate at some point your template 1 and other DBs. So we've got 3 DBs that are created by default. PSQL can non-interactively listen for us using the L option, and that's what we have just done. So for transitions, the encoding, access privileges, the names, the owners, etc. So for MySQL, whatever results return, the number of rows are returned by PSQL, whether interactively or non-interactively. So no option will list databases that are available for usage. For PSQL with no options, answers interactive mode. This is where you're able to interact with the interpreter issuing one command at a time. Press important that PG user be set, otherwise PSQL will attempt to connect as the locally logged in user with CDT, which will fail. Notice it fails. So indicating the user Postgres or setting the variable will fix for that particular problem. So now we're in, and this echoes a prompt. We know that we're within the Postgres shell prompt because prefix means Postgres as opposed to the standard bash prompt, which includes the username at the host name or some variation of. Additionally, the Postgres prompt terminates in this case with the hash mark or the pound symbol and is connected as a super user. So just know that the hash mark or trailing hash mark indicates super user, which refers to username Postgres doesn't have to be. You can indicate a different username like setting up Postgres QL. It also includes a version and the fact that you can type help out. Now there are meta sequences or meta character sequences that we may reference to give us help as well as return useful information from the DBMS. If you'd like general SQL help, use \h. Let's just note that, and that'll be our next command. \h returns SQL specific help. So in the event that you need help with a particular SQL command, execute \h. All SQL commands that are supported are returned. So your equals commands, for example, if you want help on altering a table, then you can execute \help with equals your table. And notice it displays one page full of how spacebar takes you through the list of commands, or there is create command. If resolution there is, you'll see it displayed slightly differently. So \h, for example, with create, returns the various ways in which you may use create. And always answers the question with respect to case sensitivity. Notice in this case, lowercase create returns the same. And let's try a mixed case. And returns the same. So built into the interpreter is documentation for SQL commands, which is successfully using \h as a meta character sequence or meta sequence that will return SQL specific help. And there are the various commands that may be built at any time. Now, if you'd like help on the various meta sequences that are supported by PSQL, use \question that returns PSQL specific help. So \question returns PSQL specific help, which amounts to usable meta sequences. These meta sequences are shortcuts for returning useful information. So \question mark, for example, returns a number of options. And if there's no one page full of time, adjust it appropriately to, of course, the dimensions of your screen. So if you want to see the copyright, use the copyright. If you want to execute a query from a particular file, \g. Help on SQL commands, we've already looked at. To quit, \q. These are some of the common options. \q also works with MySQL, by the way. So even if you're working between both, some things do carry over. Let's return to the interface and \question. Now, with respect to commands, you notice arrow key up, arrow key down. Cycle through those commands for us, we don't have to retype it in. And the meta sequences for various categories, including general meta sequences, query buffer, to edit the query buffer, for example, supplying a full with an external editor, the ability to modify a file which contains queries, input output, for example, copy which we're looking at as a means for inserting data into your tables as opposed to the insert command, SQL insert command, the ability to execute queries directly from a file, whether they're inserts, updates, selects, or deletes, or otherwise, drops, creates, you name it. You can reference a file directly with \i as a meta sequence, followed by the file name. And a number of other options. Now, the informational options is where we'd like to focus at this particular point. And there are a number of informational meta sequences that are of interest to us. Let's look if you're not familiar with PostgreSQL, but they become quite clear as the user. One of interest is to replicate the ability to list databases as \l. So, from there, we use lowercase l and get to the server and enumerate the databases. But whenever you're within the server monitor, it becomes important to see at all times, especially when the multi-user environment, the number of databases that are available. \l makes that possible. It lists the same thing we're able to accomplish from the command line using the L option, and that is the various databases, the free default databases that are created. Again, in the multi-user environment, this is subject to change. So \l with optional plus. Many of these commands have optional, which is indicated with square brackets, optional plus characters, and optional plus will usually return more information, usually one or two more columns of information about the object of interest. So returns list of DBs, just like lowercase l option. Now let's compare and contrast level L to L plus. Then notice that L plus returns in addition to access privileges, which is returned by L. The size of each database is included with this particular L. So that proves to be more useful, as we can see how much space on the disk the database occupies. These are 5 databases, that's small, and notice that templates 0 and 1 are identical, 5105, because we have not modified either. So they are indeed identical, initially at least. Whereas Postgres database, which contains user accounts and other information, is slightly bigger, using slightly bigger. So lists more information about options for \l. Again, command history is always available to reference what you recently executed, so you can take advantage of that at any time. So in interactive mode, you can do what you do essentially from the command line, and then some. There are more options within the terminal monitor, such as the ability to run all of these meta sequences to return useful information, as well as the ability to run any SQL commands that are of interest. So if you want to know the list of users in the central user accounts database, Using the meta sequence, du with optional plus will return the users that are configured to use the system. So returns list of users in system. System DB that is not users who are currently connected or current sessions, but rather users who are permitted to use PostgreSQL. So backslash du shows those users. Now, users and roles are synonymous. They're identical within PostgreSQL with one exception, and that is roles may also be groups. So roles, or the word role is treated to mean user or group within PostgreSQL. So you'll often see roles interchange as a surrogate for users. So in this case, the one role and one user defined is named Postgres. In order to the user, change user can do anything within the context of PostgreSQL. User currently has no membership, so member is not a member of any other defined roles. Now, du plus returns in addition to member of description information if defined for this particular command. You can assign a description to users for those types of objects for defining them. If you like, in this case it's blank, there is no description defined. The idea is backslash du lists the users that are available in the accounts database. So far, two more important to remember. Backslash out, backslash du list the databases, list the users with optional plus symbols to return more information. Now, supposing although we could always open these shells using Control-Shift-T within no terminal monitor or equivalent KDE or within macOS X or Solaris, supposing we wanted to, from within the context of your shell, that's your terminal monitor, access the operating system shell, which is normally bash. Just like with many other commands on terminal monitors like MySQL, there's a means of doing it via some meta sequence. Within TSQL, simply backslash exclamation. This returns user to your shell. Now, we'll reference the shell variable. Whenever you log into a Unix or Linux-based system, the shell variable is defined. So you may echo it at any time and it'll tell you your shell. Our shell is bin bash. So backslash exclamation will take us to the shell, which is bin bash. Exclamation, enter, that gives us a shell. And of course, if